This is JEE 2025 question on collision. In my previous video, I have solved it using conservation of mass and conservation of kinetic energy because it is assumed to have a perfectly elastic collision. I have given the link in the description where I have solved this question. Another method to solve this question is a very elegant way to solve it is by using center of mass method. I will explain how we can solve it in a few steps. So first of all, we will calculate the velocity of center of mass, that is m1 v0 plus m20 divided by this. So velocity of center of mass is 2/3 of v0, where v0 is the velocity with which our particle of mass 2m is moving. Now in case of calculating velocity with respect to center of mass, so v1 cm, that is velocity of 1 with respect to center of mass, is v0 minus 2 by 3 v0, that is 1 by 3 v0. And similarly v2 cm, initially it was 0, so it is minus 2/3 of v0. Now from here you can see a very important result, that is the total linear momentum in this case will be 0 with respect to center of mass. When you multiply it by this by 2m, which is the mass of the first particle, and when you multiply with this with mass m, which is the mass of the second particle, you will see that their sum, that is 2m v0 by 3 and minus 2m v0 by 3, this equals to 0. So what it says is that linear momentum is 0 in center of mass frame, so they will move in a straight line, and this gives a great advantage while solving this problem. So initially we can say that this particle is moving in x direction with respect to center of mass. This particle is moving in this way, and similarly the second one is moving in opposite direction on the same straight line. Likewise, after collision they will again move in a straight line and in opposite direction, like this first one will move in this way and the second one will move opposite, just opposite to it. Why just opposite? Because they have to preserve the net momentum equals to 0, so they will move in opposite direction, and this gives us a chance to solve it in a very simple way. Suppose the scattering angle with respect to center of mass is theta for first particle, so this will be pi minus theta for second particle. It will move in opposite direction. Now another important result in this frame is that the kinetic energy, that is, or you can say from the since the kinetic energy is concerned because of elastic collision, so the magnitude of velocity, or you can say speed, remains same. That is, if it is moving with velocity, suppose v1, then after collision this will also move with velocity v1. This you can verify it by yourself. Similarly, if it was moving with velocity, now this is the velocity with respect to center of mass, so v1 is velocity with respect to center of mass. Similarly, this velocity remains same, and that is v1 with respect to center of mass. These two, the magnitude of these two values remain same. Direction of course changes. Similarly, for the second particle, if it is v2 with respect to center of mass, then this magnitude will be same when it scatters, and this will be v2 with respect to center of mass. So these two results, one, that is linear momentum is 0 with respect to center of mass, and their speed does not changes in center of mass frame. These two give us a great advantage to solve this question. So let us see how we can solve it. So in this elastic collision, speeds are unchanged. Direction will change, of course, because of scattering. So after the collision, the first particle will move with 1 by 3 v0, because we have calculated the velocity with respect to center of mass as 1 by 3 v0. Similarly, for second particle, the speed will be 2 by 3 v0. And suppose I assume theta as scattering angle of 2m in the center of mass frame. So what will happen is that after this is the initial line before collision, that is along linear momentum and after collision, suppose it moves like this, and this angle is theta, and this is our 2m. So we can resolve this velocity. Magnitude remains same, so it is 1/3 of v0, and we can resolve this velocity. It will have an x component, 1 by 3 v0 cos theta in x direction, and 1 by 3 v0 sin theta in y direction. So these two will be the velocity in the center of mass frame. Now in lab frame, we have in center of mass frame we have calculated the magnitude and direction. So in lab frame, velocity of 1 in lab frame will be velocity of 1 with respect to center of mass plus velocity of center of mass. This value we have calculated with respect to center of mass in x direction, that is 1 by 3 v naught cos theta, and velocity of center of mass was of course in x direction, that is 2 by 3 v0, and in y direction it is 1 by 3 v0 sin theta, and in y direction velocity of center of mass was 0. So net in y direction and x direction we have calculated the velocity. So in lab frame, tan phi, which is the angle or the scattering angle, phi is your scattering angle, so tan phi is v1 dash y divided by v1 dash x. When we substitute the value, we get this value as sin theta upon cos theta plus 2. So what now we do, a simple differentiation is required to find the maximum, because this angle is just the tan phi is the scattering angle, and we have to calculate its maximum value. So we will differentiate with respect to tan phi is sin theta divided by cos theta plus 2. So we will differentiate it. You can pause the video and see the differentiation. Finally, this theta comes out to be 2 pi by 3. So for maximum scattering, theta comes out to be 2 pi by 3, and we plug back into our result of tan phi. Then the result is tan phi, or phi is 30 degree. So this is the end of our video. Thank you.